Well, you might not know it, but edge computing has us surrounded. From the smartwatches you wear to the computers controlling the traffic signals, edge computing has become an indispensable mode of analyzing data. One can find its use in simple hardware to safe monitoring of oil rigs to drone-mediated crop management. Welcome back to our channel. In today's video, we will talk about what edge computing is and the 10 things you need to know about it. Edge computing dates back to the late 1990s, when content delivery networks were developed to provide web and video content to users from edge servers located close by. Apparently, despite its extensive usage, only 10% of the data is processed by the edge, but this is expected to shoot up to 75% by 2025. It can be correlated to architecture rather than a single technology. It is a powerful mode of computing that results in an increased response time while reducing bandwidth usage. As more Internet of Things IoT devices like watches, phones are deployed worldwide, these connections will undoubtedly get more complex. The market is growing and providers are launching new services to improve cloud and edge processing synchronization. Number 1. What is edge computing? This modern computing system puts data sources closer to business applications such as IoT devices and local edge servers. It is a form of data processing that can be used in many ways and in various varieties. Good ideas, faster response times, and higher availability of data are all significant advantage of being close to its source. In simple words, it is the practice to capture, process, and analyze data near the source where it is created. Number 2. Why edge computing? Large amount of data have come from the rapid growth of IoT devices and their rising processing ability. Data volumes will continue to climb as 5G networks boost the number of connected mobile devices. Cloud and AI promise to automate and foster innovation by delivering actionable insight from data in the past. However, the extraordinary amount and complexity of data generated by connected devices have passed network and infrastructure limits. Sending all that information to a central data center or the cloud causes bandwidth and latency problems. Because data is processed and examined closer to the point of use, edge computing is more cost-effective. Why? Because data does not have to travel over a network to a cloud or data center to be processed, and the latency is considerably lowered. Edge computing, particularly on the latest 5G networks, enable deeper insights, faster response times, and better user experiences by processing data more quickly and thoroughly. Number 3. Harnessing the potential of devices at the edge. Calculating the amount of data generated by electronics in our society is quantifiable more than ever before. From connected cars to intelligent workplace bots, much of these IoT data is never mined or used. According to McKinsey & Company study, an offshore oil rig collects data from 30,000 sensors, but only 1% of that data is used to make decisions. Edge computing makes use of the growing capabilities of in-device computing to provide near real-time deep insight and issue a predictive analysis. Increased analytical capabilities in edge devices have their potential to spur innovation and increase quality and value. It also focuses on key success problems such as success. How do you control the deployment of workloads that do this work set in the presence of additional compute capacity? How can you use embedded intelligence in devices to improve your employees, customers, and companies' operational processes? We will answer these questions along with the video. To get the most value out of such devices, a significant percentage of computing must be shifted to the edge. Number 4. Things to think about on your way to edge computing. You may use edge computing to tap into the large amount of untapped data generated by connected devices. You can identify new business opportunities, increase operational efficiency, and provide your customers fast, more consistent, and dependable experiences. The best edge computing models can help performance by evaluating data locally. When done correctly, edge computing may help maintain up-to-date workloads according to policies, guarantee privacy, and meet data residency laws and regulations. However, there are specific problems with this method. Threats to network security, administrative challenges, and latency and bandwidth limits should all be addressed in an effective edge computing strategy. You should be able to manage your workloads on any number of devices and across all clouds using a workable approach. It also considerably helps deploy apps to all edge locations quickly and reliably. Number 5. Key capabilities of edge computing. If you're searching for a cloud edge, you'll land it at the perfect place at an IoT edge or mobile edge computing. It helps develop service offerings that can support edge deployments. It eases utilization of near-edge data center deployments to control and manage data. A predominant increase in connectivity, capacity, and deployment of many more services from the core to the edge is achieved. It also defines what has to be managed at the border. In short, it is a comprehensive solution to many of the mentioned issues. Number 6. What is the network edge? In Internet devices, the network edge is the point where the device or the local network that supports the device and communicates with the Internet. The term edge can refer to a user's computer or the CPU within an IoT camera, as well as the user's router, ISP, or local edge server. The fundamental fact that is, unlike origin and cloud servers, which might be located thousands of miles away from the device they connect with, the network edge is physically close to the device. Number 7. How does edge computing differ from other types of computing? The first computers were enormous, expensive machines that could only be taken directly or through terminals, essentially computer extensions. Because of the invention of personal computers, computing has become popular. In the case of personal computing, applications were performed and data was saved locally on a user's device, or in some situations, in an on-premise data center. Cloud computing, a relatively new technology, has several benefits over on-premise computing. Cloud services are pooled in a vendor-managed cloud or group of data centers that may be viewed from any device via the Internet. On the other hand, cloud computing might cause delays due to the distance between consumers and the data centers where cloud services are hosted. Edge computing brings work closer to end users, reducing the distance the data must travel, but maintaining the centralized features of cloud computing. To sum it up, early computing consisted of centralized applications that could only be run on a single system. A set of decentralized apps that run on a single machine is known as personal computing. This hosting of centralized applications in data centers is referred to as cloud computing. Edge computing is a technology that describes centralized apps that runs close to users either on the device or at a network's edge. Number 8. What is an example of edge computing? Consider a home with a bunch of high-definition IoT video cameras protecting it. These dumb camera outputs are raw video signals and upload in real time to a cloud server. A motion detection application on the cloud server examines the video output from all the cameras, ensuring only clips with activities are saved to the server's database. The massive volume of video footage being transferred uses a large amount of bandwidth, putting constant and severe strain to the building's internet infrastructure. However, because it must process video from all the cameras simultaneously, the video server is under a lot of pressure. Consider moving motion sensor analysis to the network edge. What if each camera used its internal computer to operate the motion detecting software and then upload the footage to the cloud server as needed? Bandwidth usage will be drastically reduced because much of the camera's footage would never have to go through the cloud server. Thus, because the cloud server is only responsible for storing the actual footage, it can communicate with a more significant number of cameras without becoming overburdened. This is what edge computing looks like. Number 9. What are the possible use cases for edge computing? Edge computing can help a wide range of products, services, and applications. Some of the possibilities are as follows. Security system monitoring can be carried out as previously stated. Internet of Things devices. Smart devices that connect to Internet can benefit from running code on the device itself rather than in the cloud for more efficient user interactions. Self-driving vehicles must react in real time rather than waiting for commands from a server. By running code on a CDN edge network, an application can adjust how content is cached and provide content to its users more efficiently. Medical measurements must respond in real time without waiting on a cloud server's response. Given the high bandwidth requirement of interactive live video, putting back-end services closer to the video source can help reduce lag and latency. Number 10. What are the benefits of edge computing? Cost savings. Edge computing helps to save money by reducing bandwidth use and server resources. According to a recent survey, over 75 billion IoT devices will be in use worldwide by 2025. With intelligent cameras, printers, thermostats, and even toasters in every home and office, a significant amount of computing will have to be moved to the edge to support all those devices. Performance. Another important benefit of shifting operations to the edge is a lower delay. a delay is introduced every time a device wants to communicate with a remote server, because each message must be sent out of the building, communicate with a server somewhere across the globe, and then be returned before it displays on the recipient's screen. Two employees in the same workplace speaking over an IM platform may experience a large delay. If that process was moved to Edge, the company's internal router was in charge of transferring intra-office communications. The apparent delay would be avoided instantly. In conclusion, edge computing has emerged as a better data management means with lower connectivity costs and better security practices. The reliable and uninterrupted connection gives way for more ease and precision of the various devices dependent on this revolutionized mode of computing data. Do you think we covered all the basics of edge computing? Do you want to know more about computing technology? Let us know in the comments below.